let's go. Minute 13. Let's go. I'm ready to go, but my board is not ready to go. Now my board is ready to go. All right, let's rock and roll with minute 13. Minute 13. All right, and you all know what I'm going to say about this expression. We need to follow the order of operation. In short, we like to use the acronym PEMDAS, okay? P stands for parentheses, E stands for exponents, M and D stand for multiplication and division, A and S stand for addition and subtraction. So we're going to check for parentheses first. Do we have any parentheses? Yes, we do. And then inside the parentheses, we still follow the order of operation, but thankfully, the only operation in parentheses for this problem is addition. So we're going to bring over the 3, and we're going to add 4 plus 2, which is 6, plus 1 is 7, okay? Next, do we have any exponents? Nope. Do we have any multiplication or division? Yes, we have multiplication. This is 3 times 7, which is 21. And your final answer is 21. I always encourage students, always write out the order somewhere and just check it. It really helps with keeping the problem organized and make sure and helping you ensure that you are solving each operation in the order it should go. Okay? All right, number 2, if 6 pennies are in a pile, are in each pile. Okay, how many pennies are in 9 piles? All right, so we're talking about 9 piles here. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. And 6 pennies are in each pile, and there are 9 piles. So there are 6 pennies in this one, and 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 this one. So you could add each time, right? Or in short, you can do 6 times 9 because there are 6 pennies in each pile, and there are 9 piles, so there are a total of 54 pennies. 54. Okay, and next we have a fill in the blank here. If I have 9, I'm going to subtract some number in order to get 3. I'm going to subtract some number in order to get 3. So, or I can look at it, 3 plus, we can work in reverse. 3 plus what will give me 9? 3 plus 6 will give me 9, so 9 minus 6 must give me 3. You can always do the inverse of the sign when you're solving problems like that, okay? And next, it's a nice multiplication problem. 7 times 4 will give us 28. Done. All right, let me clear out our work, and let's get the problems here. I think I can fit them all there. There we go. All right, number 5, and we have another expression. As you can see, problems, expressions, you're going to see these a lot in middle grades math. And once again, I'm going to write out our order of operation to guide our operations. So, do we have any parentheses in this problem? Nope. Any exponents? Nope. Any multiplication or division? Yes, we have multiplication. So let's do that first. So this problem becomes 12 minus, what's 3 times 4? 12, right? And now we're left with addition and subtraction. So 12 minus 12 is 0. Done. Done, done, done. And you will see as you continue to practice expressions, practicing the order of operations, you're just going to get better and better and better with it. As with anything in math, it just comes with practice, okay? So now we have 8 times 10. This means to multiply. 8 times 10 is 80, okay? Next problem up, we have if 65 plus A is equal to 71, then A is equal to. So this is similar to, I'm going to write it out over here. This is what we call a one-step equation. And as I mentioned with, I believe it was problem number 4, you can do a little bit of inverse work here. So because this is a positive 65, so the sign is understood to be positive here. When you don't see it, it's understood to be a plus inside or in front of the number, all right? So we can do the inverse of that to solve it. So we can subtract 65 to help us solve it, okay? And now we have A is equal to, we do a little bit of regrouping here because you can't take 5 from 1. And we're going to borrow here. And so 5 from 11 will give us 6. Let's double check. 6, 7, 8, 9, 10, 11. So A is equal to 6. And you can always plug your answer, A, which is 6, back into the problem to make sure it works out. 65 plus 6 is 71. So 71 is equal to 71. So it's always good to check your work. Okay? Nice. So let's move on to 24 divided by 8. So let's translate this to an actual problem. 24 splits into 8 groups, or 24 divided by 8 is 3. And once again, I could think opposite. If 24 divided by 8 is 3, then 3 times 8 must be 24. So you can kind of do a little bit of backward and forward with the opposite operation to check your work. All right. Next up, we have if A is equal to 9, then 5 times A. Once again, you read this as 5 times A. So when I substitute in the value of 9 for A, it now becomes 5 times 9, which is 45. All right. And next, we have 12 quarters is equal to how many dollars? 12 quarters is equal to how many dollars? So I'm going to draw out 12 quarters. Let's do a visual. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And I know that 4 quarters equals $1, right? 25, 50, 75, 100. Quarters have a value of 25 cents. So 4 quarters is equal to $1. So that's my first set of quarters. That's my first 4. That would be $1. My next 4 would be another $1. And then my final 4 would be another $1. So 12 quarters is equal to $3. Once again, because there is $1. 4 quarters makes up $1. So if you have 12, you will have $3. Okay? All right. I will see you all back with your workbooks, as I always say, for minute 13. No, for minute 14. All right. See y'all later. Bye.